Hi students, this is Suchadata teaching economics to class 11 and here I am with the third chapter of your statistics book and the name of the chapter is Organization of Data. In the chapter before this, we read about the difference between sampling and census. In this particular chapter, we are going to discuss about the classification of data. If you keep your books in the book rack in an haphazard manner, it will be very difficult for you to find out which is your history book, which is your economics book, which is your bio book. But supposing you put your books in some order, for example, as science book, SST book, maths book, it will be easy for you to find out where your book is. Similarly, when we classify data, it is easier for us to derive the information that we are trying to. Well, the raw data which we get first of all is not at all meaningful, but when it is classified, that is the time it becomes meaningful. For example, if I say there are 20 students in a class and they have got marks as 18, 16, 19, 20, say 75, 83 and I bring down the marks of 20 students. It is very difficult for me to find out which student has got the least marks, who's got the highest marks, which is the student who has got the marks at the midpoint and so on. Thus, when the data is there in a raw shape, it is in this manner, but we have to classify this data in order to make it meaningful. Well, organizing or classification of data, as I said, is essential because otherwise we cannot derive the information which we are looking forward to. Each division of data, that is 20, 18, 16, 75 is called as a class. And this, when it is grouped, when it is arranged, the process is called as the classification. Now, why do we need to classify data? If we have to be more clear about it, we must understand that the data needs to be classified because this makes it simplified. A simple data is very easy to understand and thus this is the requirement of statistics. Besides, the utility of the data can be achieved only if it is arranged, if it is classified and not in a haphazard manner like this. It also gives it the shape of distinctiveness and it is very easy for a person to compare the data with other datas or within the data the figures if it is presented in a classified manner. The data also becomes very effective because the information can be derived instantly and that is why the classification of data is required. Now, this what you are seeing is the raw data. If I have to present it in a classified manner, I am going to either put it in an ascending order or going to put it in descending order and thus this is how we will know that the data is not now in a raw form because then I will be putting as 16, 18, 19, 20 or say from upwards 75, no, it will be 83, 75 and so on. This is how we have to present the data either in ascending or descending order when it has to take the shape from the raw data to a classified data. Now, let me talk about the various forms of data or the various forms of classification of data. And in that, the first is the geographical data. This is based on location and the example can be if I say that these many bicycles are manufactured in this particular state. I am just taking a raw figure. Say for example, 1000 bicycles are manufactured in Haryana, 900 are manufactured in UP, and so on. So when I am talking about the data based on the location, that is a geographical data. Now the other data are chronological data, which means based on time. Now same if I talk of bicycle manufacturing, I will not be talking of the state, the location, but I will be saying 1000 bicycles were manufactured in the year 1995, 900 in 1996, and so on. When I talk in terms of years, it will become as chronological data. Next is the qualitative data. Qualitative data is when we talk about the attributes of quality of a person: honesty, tall, handsome, fair, or say dark complexioned, and so on. In this, there are two kinds of subdivision: the simple qualitative and the manifold qualitative. For example, simple will be that there are these number of males and these number of females in an area. Say if I talk about Noida, then it is that there are 1000 males and 900 females staying. But when it becomes manifold, then the data will go further. The 1000 males and the 900 females which are there, out of the 1000, say 800 are employed, 200 are unemployed, and same goes for the females. Then I talk about their after the employment, I will talk about where they are staying, what is their income, and how long they have been staying. So when I can derive more information, when the information is more about the qualitative aspect, it is the manifold data. But when it is just simply giving you one information, then it is the qualitative data. Then we talk of the quantitative data. Quantitative data is whenever we talk about something in numbers, numerical values are given, the variables are there, that is the time it is a quantitative data. Most of the data are quantitative in nature. Now let me talk about the variable word. Variable actually means whenever anything is represented in number and it can be measured and it keeps on changing is the variable. For example, say the bicycle manufacturing is 1000 and next year it becomes 900, then 1100, then 1300. So I can measure it, it is in numbers and it keeps on changing is a variable. Now this variable are again further subdivided into discrete variables and the continuous variables. The discrete variables are when complete number is given. The 1, 2, 3, 4, 5, 6, 7 and so on. This is a discrete variable because the whole number is there. And this can be number of people, number of cities and so on. But when the continuous variable comes, it is that we just cannot base our information on whole numbers, it has to be divided into fractions. For example, the height of a person is 5.1, 5.2, 5.3, then it becomes a continuous variable. So the basic difference between a discrete variable and a continuous variable is that here the numbers are whole, whereas here the information is in fractions. The raw data that we are talking of is cumbersome, lengthy, haphazard, not easy to handle. Therefore, we put this raw data into series. Series means that we put the data in order or sequence, and thus now we are going to study how the raw data is presented as statistical data. When we talk of statistical data, it is of two types, the individual series and the frequency series. In this, first of all, I am going to talk about the individual series. Individual, as the word is indicating, it means single. Okay, the information that we will be deriving will be single. And this individual series can either be put in ascending order, descending order or serial number. And I shall teach you all of them. Say for example, serial number, how will we put it? Then we will say roll number and marks, right? This is I am teaching you serial number individual series. It will be roll number 1, 2, 3, 4 and 5. Roll number 1 has got say 60 marks. Roll number 2 has 80, roll number 3 has 40, roll number 5 has 70 and roll number 5 has got 50 marks. This kind of individual series is called as the serial number series, right? Now, I will be converting this same data as ascending data. Now, ascending data will be, it is roll number, which is the least here that we will be talking of. Roll number 3 has got 40 marks. Then roll number 1 has got, roll number 5 has got 50 marks. Roll number 1 has got 60 marks. Roll number 4 has got 70 marks and roll number 2 has got 80 marks. When this variable, when this is presented in ascending order, then it is called as the ascending order individual series. The number, the information that we are getting are of an individuals only, but they have been presented in the ascending order. Now, let me put this data into the descending order. It will be roll number 2 gets 80, roll number 4 gets 70, roll number 1 gets 60, roll number 5 gets 50, roll number 3 gets 40. So, this is the descending order. Here again the information is same, but now it is based on descending order. Now, you see how easy it has become. Supposing I were to just put it in raw form, in the raw data, I will be saying 60, 70 and 50, 40 and the last number that is left is, I have talked about 60, 70, 80, 50, 40, okay. You will not know what is happening, where is the highest one, where is the least one, neither do you know that which roll number has got or which roll number has got what marks. Thus, this raw data, when it is presented in individual series, it is presented in three forms. It could be in serial number, you know roll number 1, 2, 3, 4 immediately. If somebody asks you roll number 3 has got how many marks, you know 40 marks. When it has to be presented in ascending order, somebody asks you which is the least marks and by whom, you will say roll number 3 40 marks. Descending, then again it is very clear which is the highest marks, roll number 2 80, least roll number 3 40. So, thus the presentation of data in the individual series as the series of serial number ascending or descending is making it very easy for us to understand. And this is the conversion of raw data into statistical data. The second part of the statistical series is the frequency series. Now, this frequency series is further divided into array series and distribution series. The array series is the discrete series. Now, before I talk about these two series, that is the array series and the distribution series, let me tell you the meaning of the words which you must know, and those are frequency. What is a frequency? The number of time a particular number repeats itself is the frequency. Say 3 students have got 30 marks. So 30 is repeated 3 times in that data. So the frequency here will be 3. Next is class frequency. It again means repeating, but repeating in sense of corresponding to range of value. For example, here I said 3 students have got 30 marks. But when I talk of the corresponding range of value, I will say between 20 to 30, the students have got 3 marks. So, here it will be that between 20 to 30, there are 3 students who have secured this marks. Next is tally bars. Tally bar means every time a particular number repeats, you put 1 bar, that is like this. But after the 4th bar, 1, 2, 3, 4, the 5th bar is like this. You cut it, right? That's called as the tally bars. Now, let me talk of the frequency array or the discrete series. Here I will be talking about the marks of the students, and I am putting them in the frequency array, and that is the discrete series. And these are the marks of 20 students, say of class 11 economics. Okay. 11 marks are obtained by 3 students of the class. So that means 1, 2, 3. 12 marks are obtained by 1 student. So that means 1 bar. 14 marks are obtained by 4 students. 1, 2, 3 and 4. Then 16 marks are obtained by 2 students, right? So it will be 2. 17 marks are obtained by 5 students. As I told you here in the tally bar, so it will become 1, 2, 3, 4 and 5. 18 marks are obtained by 1 student. And 20 marks are obtained by 4 students. So 1, 2, 3, 4. Now supposing you have to see whether your bar, that is the frequency array series, is correct or not. How are you going to do it? You see, you have got the marks, you have the tally bars, you have the frequency. So you are going to add up this frequency, the number which is there, and it should total the number of students that you have been talking of. I said 20 students. 3 plus 1 is 4, 4 plus 4 is 8, plus 2 is 10, plus 15, plus 16 and 20. When it is 20 and I was talking of the 20 students, if the frequency matches to the number of students which have been given in the question, that means it is a correct frequency array discrete series. That is, the number or the frequencies should match to the total number of students as required. Now let me talk about the frequency distribution. In the frequency distribution, we will be talking of the range, okay, and this will be like from 10 to 15, 4 students have got marks in between, 15 to 28 have got, 20 to 25 say 6 have got, 25 to 30 say 9 have got. So when it is in this form, that is the class interval which is there, that is the time that this becomes the frequency distribution. Simple meaning is, when the data is presented in the mode of class intervals, it is termed as frequency distribution. Now, this frequency distribution data also has 2 types. It is further divided into 2 types, exclusive series and the inclusive series. Now, exclusive series are also called as the series wherein we exclude the highest number which has been taken, and it is excluded here, but it is included in the next figure. Meaning to say, when I say from 10 to 15, 4 students, actually I am saying from 10 to 14. And this 15 comes to the next one. This will be again I will be taking from 15 to 19. 20 I will be not including in this class interval. I will be excluding here. When I exclude it, it becomes exclusive series. Then I will include this in the next one, 20 to 25, but actually it means 24. So when we exclude the upper limit of the class interval, that's termed as the exclusive series. Now let me talk of the inclusive series. Inclusive series is when I include the upper limit in the series that I have, that is the class interval that I have, it's called as the inclusive series. For example, 10 to 14, I mean 10 to 14. Say 9 students. 15 to 19, I mean 6 students. There is nothing that I am in, because this is included here only and the next number does not include it. So that is why. Then it will become from 19, it will become 20 to 24. Okay. Then it will be say from 25 to 29. Though it also means the same. If you see 10 to 15, 15 to 20, 20 to 25. Here also I am talking of the same, but then what is happening is here I have excluded the upper limit in the class interval and have included that particular number in the next class interval. Here what I have done is I have included the upper class limit in the class interval. I have kept it where it is and I mean it. That's called as the exclusive series and the inclusive series. Now let me talk about the shortcomings of the frequency distribution data. Here first of all, we have to understand that no detailed information is provided by such data, and there is loss of information because it's not easy for us to know exactly who's got how many marks exactly. It will be in range, class interval, in series, and thus the individual information is carrying no significance as to who has got the highest marks. This we will never know. We will know the range of the highest marks obtained. Thus, those are the shortcomings. Now, let me talk about the univariate distribution and the bivariate distribution. The word uni means single, bivariate means more than one, and thus uni means one information derived. As I gave you the example earlier, the same will come in the univariate distribution. For example, there are 20 students and their marks. So, I will say roll number 1, 2, 3, 4, 5 and the marks obtained by them. If I just write them in series, that is going to be univariate distribution because it is giving us uni information, one information. But the bivariate information is when we are deriving information of more than one. For example, I want to know that there are 20 firms. How much have they spent on advertisement in a particular year? For example, if I say that in the year 1995 to 96, did they spend between 115 to 125 or between 125 to 35 or say 135 to 145 and 145 to 155, then I will put it as, say here the number of firms that had spent in this category were 3, those who spent here will be 7 and here will be again if I say 6 and 4. So, this is what I am calculating as the money which was spent on advertisement of the 20 firms. Next year again I pick up in the next year how much did they spend. It could be that it becomes different, the data. So, thus when the information is derived of more than one person, one organization, that is the time it becomes a bivariate distribution. So, in this chapter you have understood why classification of data is required, why raw data are not good and why we have to put them in ascending series, descending series or into other such univariate distribution, bivariate distribution and so on, and thus it becomes easy for us to handle, to gain information, and thus it does not remain cumbersome, lengthy and uninformative. That was all about your chapter. Thank you.